Hi there, this is a rough recording of how to solve subsets 2, which takes an array with possible duplicates, such as this example. So as you can see, there are two dupes here. There are two instances of the number 2, and the goal is to generate all subsets of a given array. So if you take this as an input, then the subsets are the empty set. There's 1, there's 2, there's 1, 2, and 1, 2, 2, and also 2 and 2. So it's basically, it's given here, right here. So how do we do this problem? Well, let's consider what happens when nums is empty. So let's say nums is empty. What we want here is the empty array. That's what we want to return. However, if it's non-empty, then here's how we can sort of approach the problem. We know that the result is going to contain at least the empty set. So we're going to sort of iterate through this array, and for each element, we're going to generate, we're going to take all the elements in the result, clone them, and then add this, add the current number, and we're going to repeat that. So I'll do this a few times, and it should be clear what's happening. So on the initial pass, there's only one element in result. So S is for start, E is for end, and the current element that the current element of result that we're working with is going to be called, we're going to point to it using J. And we're going to create a variable for new subsets. We're going to call it S. For now, it'll be undefined. But let's start I. So we're going to iterate through this input array. So this is the input array. So I is pointing to 1. So what we're going to do is we're going to iterate through all elements of the result, basically from S to E. Actually, E is over here. E is exclusive. Then we're going to clone each element of the result. So we're going to clone this. We're going to create a copy of this element right here. We're going to store it in S. Then we're going to append what I is currently pointing to S. Then we're going to add this to the result. So that's what happens. So then we increment J because we're iterating through a result from S to E. We're at E here, so we're going to stop. So next we move I forward to the next element. And so E is going to be here now. So so we want to iterate through the result prior to the addition of new subsets generated by appending 2. So we're going to move J back to S. So J starts off here. We're going to clone this and store it in S. And then we're going to append 2. So 2 goes here. Then we're going to append the subset we just created to the result like this. Oops. Like that. Then we're going to move J forward because we're iterating through the result. Then we're going to clone this. So we have 1 here. Then we're going to append the current element that I is pointing to the new subset we created. Then we're going to append the new subset we've created to the result. So this is going to go here. Then we move J forward, and J is at E, so we're done. So then we move I forward. So notice here that there's a dupe. This is the same as the previous number. So if we start J here, here's what happens. We're going to clone this. Then we're going to append 2. But notice that 2 already exists here. So we want to skip this, and we want to skip this because we've already cloned these and added 2 to them. So really, we only want to clone the subsets that were generated in the last iteration when we were processing this. So we're actually going to move S to E like this. And then E is going to go to the end of the result array as usual. So watch what happens. So J starts off at S. We're going to clone this, and that becomes this. Then we're going to append 2, which is what I is currently pointing to. Then we're going to add the newly generated subset to the result, like that. Then we're going to push J forward. We're going to clone this as usual, as we've done before. We're going to get this here in S. Then we're going to append the element that I is pointing to. And then we're going to append the newly generated subset to result. And notice that if there were another 2 here, so then we move J forward, it hits E, we're done. If there were another 2 here, then processing this and this, they're both redundant. So if we were to clone this and append this, we're going to get this again. So again, as before, we want to start S at the previous value for E. Then we're going to move E to the end of the array. And we're going to continue. So let me go ahead and code this up because the code might make more sense. So I'm going to reset everything. So let's start on, I'm going to reset the state diagram to the initial state. So this is undefined right here. So remember what we said, which was that if nums is empty, then we're going to return the empty set. So if not nums, we're going to return the empty array. Otherwise, the result is going to contain at least the empty array. So we start off there. This is what we're returning. So we're going to iterate across nums. And the code for that is just like this. And for each iteration, for each element of nums, we're going to iterate from S to E. So E is the size of the result array. So let's do start is 0, end is equal to the length of the result. And J is going to go from S to E. So what do we do here? So we're first going to clone what J is pointing to. So here's what that looks like. We're going to store it in a variable called S. So S is equal to, that's what this does. This creates this clone right here. Then we're going to append the value that I is pointing to. That. Then we're going to append, so that's what happens. We append the value that I is pointing to the newly created subset. Then we're going to create the newly created subset to the result. So we get this. Here's how you do that. Then we move J forward. We hit end. So we're done with this iteration. Then we move I forward. That's just this loop right here. That's what this loop does. So start is back at 0, and end is over here, which is the length of the result. It's 1 past the array bounds. And we're going to do this again. J starts off at start, which is 0. And then we're going to start by cloning this. So that's what this line does. So this is the empty array. Then we're going to append the value that I is currently pointing to, which is 2, to the newly created subset like that. That's what this line does. Then we're going to append this to the result. So this goes over here. Then we move j forward per this loop. We go ahead and create a clone or a copy of what j is pointing to. So that's what this is right here. Then we're going to append the number that I is currently pointing to, which is 2, like this. Then we're going to append the newly created subset to the result, like that. Then per this loop, we push j forward. J is at end, so we're done with that iteration. So then we move I forward. And this is where we do something different. So notice we want to skip over this, and we want to skip over this. We basically want S to start at the previous value for E, just like that. So how do we do that? Well, if there's a dupe, as we have here, so if there's a dupe, there can only be a dupe if I is greater than 0, like this. Then we're going to move start to the previous value for E, and otherwise we'll start at 0, which we were doing before. So here we do have a dupe. So I is at a 2, and the previous value of I, or what I was pointing to before, was a 2. So this is true, and we put S at E. Then we move E to the to just after the array. So let's execute this code right here. So J starts at S, of course. So sorry, this is over here. I meant to move E, but I moved J instead. So J starts off at S. We clone this. So that's 2 right there. We append the current value that I is pointing to, which is 2. So we have this new subset right here. Then we append this new subset to the result array, like that, which I can just copy like this. Then we move, then per this loop, we move J forward. We clone this subset right here. So we have this. We append the value that I is currently pointing to, which is 2, to the new subset, like so this happens. Then we append the new subset to the result. So this is what we get. Then per this line, we push J forward. We hit the end. And then we move I forward, and we're done. So this is actually the correct result. As you can see, it matches what was output here. Let's test it on the examples. That works, and I'll just submit it. I've practiced. Oh, no, there's a problem. Oh, you know what I forgot to do? I forgot to sort. So I assumed that the input array was sorted. That's not necessarily the case. You have to sort it to put the duplicates next to each other. So that's what I got wrong. And there you go. I'm going to snapshot this and put this into the progress stream. Like that. Cool. Well, that's done. That is subsets 2. Oh, let me go over the time and space complexity. So this creates a new subset. This loop creates a new subset. And how many subsets are there? There are 2 to the n subsets, where n is the size of the input array. The cost of creating each subset is potentially n. So the time complexity, because n is the size of the input array, the biggest subset is the entire array itself. So the time complexity, it's going to be n times 2 to the n. And space, well, we're not, so the space we're using, we have these pointers. It's really just the output array. it's just result, which we typically don't count in the space complexity, but we'll do so anyway in this example. So there are 2 to the n subsets that we produce, and each one is could be of size n, because n is the worst case. It's when the subset includes all elements. So that's the time and space complexity, that is the submission, and that is the problem. So hope that makes sense. Let me know if you have any questions.